Alright, I'm Gavin. This is the low pass filter circuit. So here we have resistors, and they're in series because we had to make an equivalent resistance of 1.5 kilo ohms. But these are together 1.5 kilo ohms. And then here we have a capacitor. And so what we're doing is we have our input is a sine wave signal that we're going to sweep from 1 kilohertz to 1 megahertz. So we get a range and see what happens. And then we're measuring the output here on this side of the capacitor relative to the input. And so what we see when we do the sweep is that for low frequencies, they're the same. You can see they're on top of each other, the output and the input. But then at higher frequencies, it starts filtering out some of those frequencies and starts attenuating the signal so that the gain becomes more and more negative of the output, and this is the input is staying the same, obviously, for these high frequencies. And that's because the low pass filter, what it does is it takes those higher frequencies and attenuates them so that they're not as present. Okay, Gavin, this is my bandpass filter. So this is going to be the waveform as we do a network sweep through 1 kilohertz and through 1 megahertz. So at the lower frequencies, there's a lot of attenuation, and then it increases up until the resonant frequency where there's very little attenuation, and then it goes back down. And that's because a bandpass filter has a very specific range of frequencies at which it does not, the gain is very small, or the gain is close to zero, but then for all other ranges of frequencies, the gain is very small and very negative because it's really attenuating those frequencies, which we see here and here. And also we see the phase response shift here goes from out of phase in one direction, and then at the resonant frequency, it's in phase, and then it switches to the other and becomes out of phase in the other direction.